Hi, my name's Stewart Lynch. In this video, I'd like to take you through the process of creating a custom TimerView. We'll focus on design and reusability so that you'll be able to add it to any one of your projects in the future. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. So this is what we're going to create. I'd like to create a timer object that we can specify a color and a length for. And then when I want to pass that object into a custom timer view along with a Boolean value that'll determine if we want to show controls or not, the timer gets laid out on the screen and the size of the timer and text will adjust to the amount of space provided. You can even set a particular frame, otherwise it'll just take up the entire space. And for those views that have controls, you can start and stop them at will and reset them. Behind each one of these buttons is a function that controls the timer. So if you have no controls, you can display a timer without it and control the timer programmatically, like I've done here, where I sleep for 10 seconds when the view appears before starting the timer. And each timer is independent of the other. So, keeping this design in mind, let's get started. There is no starter project for this video, but I do recommend that you work along with me to build out the solution. A link to this completed source code will be in the description, but working along with me will ensure that you understand what I'm doing, and it'll allow you to make your own modifications. So let's start by creating a new Xcode project using the iOS app template. I'm going to call mine Custom Timer, and I'm going to save it to my video folder for now. The first thing I'd like to do is to create a class that'll be observable and will contain all of the properties that my timer view might need. So let's create a new file that we'll call TimerObject. And then inside that file, we'll create a new class called TimerObject, and we'll mark it with the observable macro. Now I'll change the import to SwiftUI as we're going to be creating a color property. So when I create our timer view, I want to be able to specify a timer color and a timer length. So I'll need to create two let properties for those since they don't need to change after we create the timer. So the first one is going to be timer color, and that's a color. And the second one will be length, which is an int. Now these are the only two properties that I'll need to pass into the view. All other properties will either have default values set, or be optional, or be computed properties. So since this is a class, I'll need an initializer. The first of our properties with the default value will be our timer. Now there are a couple of different ways to create one in Swift. One is by using combine in a publisher, and the other is to create a timer NS object. So I'm going to go with the latter by first creating an optional timer that will be initialized as nil. So it's optional nil. We're also going to need how much time has elapsed. So when we create the view, we can initialize this as 0. And then we'll need another property to track whether or not our timer is running. So I'll create a isTimerRunning as a Boolean and initialize it as false. Now the remaining properties are going to be convenience computed properties. It's going to be very helpful when we display our UI to know what the remaining amount of time will be. So this can be computed using simply the subtraction of the time elapsed from the length. Next, in order to create our UI and determine what angle we want to move our circle indicator around the arc, we'll need to know the fraction of the progress that has been completed. So we'll create another computed property that is progress, and it needs to be a CG float. And we find this by subtracting the remaining time from the length and converting it to a CG float, and then dividing by the length itself, which also has to be a CG float. Now we'll need to execute 3 functions that'll be behind those buttons. One to start the timer, one to stop or pause it, and one to reset if we wish to use the same timer over again. So I'm going to create a function called start timer. And the first thing that it's going to do is to set is timer running to true. After that, I can create a new timer and assign it to our timer variable, that optional. We'll use the timer scheduled timer constructor that asks for a timer interval, whether it repeats, and then it has a closing block. So for the time interval, I'll specify 1 for every second. And then for repeats, we'll say true, so that it'll continue to set the timer until we invalidate it. And then I can tap on the trailing closure. And this will give us a timer, but we don't really need this, so we can replace it with an underscore. And since it's a trailing closure, we can remove the block label and move the closing parentheses to the end of that repeats argument. So I'll want to stop the timer once the remaining time reaches 0. So in the body of the trailing closure, I will check to see if the remaining time is greater than 0, and then I'll increase the time elapsed by 1. Else, I'm going to call a stop timer function that I'll need to create now. When you do this, though, you get a warning that a reference to the 2 properties in the closure require an explicit use of self to make the capture semantics explicit. So you can tap on the fix and it'll insert a strong reference to self in the closure. So now let's create that stop timer function. Again, we'll check to see if is timer running. And if so, we can set it to false and then call the timer's invalidate function. Now we can go back to start timer function, and in the else clause, we'll call that function. And then the last function is that reset button function that will reset the time elapsed back to 0 and set is timer to false. Before I finish here though, I'll be creating a play, pause, and reset button as you saw in my view, and I want to be able to disable those functions or those buttons depending on the state. So for example, when the timer is running and the remaining time is greater than 0, I want the play button to be disabled. So we'll create a computed play button disabled Boolean property. And then I can use a guard check to check if the remaining time is greater than 0 and the timer is not running, else I'll return true. If those conditions are met, I'll return false. So for the pause button, I'll only want it to be enabled if the remaining time is greater than 0 and the timer is running. So we'll create a computed property for pause button enabled, the Boolean. Again, I'll use a guard check to check that the remaining time is positive, greater than 0, and the is timer running is true. Else, I'll return true. And if the conditions are met, I'll return false. And finally, for the reset button, we'll want to make sure that our remaining time is not the same as the initial length, which would mean that we haven't started yet. And the timer is not running. Otherwise, we'll return true. If those conditions are met, we'll return false. So let's fix this typo here first for progress. Well, that completes the entire TimerObject class, and all we need to do now is to create our reusable TimerView. So let's create a new SwiftUI view and call it TimerView. And when I create this view, I'll be passing in a timer object, and I'll also be passing in a Boolean value called controls that will indicate whether or not we want to show the start, pause, and reset controls, or just display the running timer. So let's create 2 let properties for those and fix the preview by creating a sample timer object, say with a timer color of red and a length of 20. Now, in order to display my length and remaining time in a nice format, I want to create a function that we'll call display time. And it's going to accept the total number of seconds and then return a string. So first, we'll say let minutes to be the total number of seconds divided by 60. And since length is an int, the remainder will just get truncated. And then to get the seconds, I can use the total seconds %20, which will give me the remainder when we divide by 60, which will be the number of seconds. Then I can simply return the string using the format and within quotes %01d colon %02d. And for that 01d or the 1d, it's minutes, and the 2d is going to be seconds. Now in the middle of my view, let's create a text view using the function to convert the timer object's remaining time. I'm going to apply a monospaced digit modifier. I want the font to be large, so let's use a system size of, say, 100. I'll apply a foreground style that will be the TimerObject timer color. I'm going to make it bold. And then to make it flip like you see on a digital alarm clock, I'm going to apply a content transition of numeric text. And then I'll need to set an animation, so I'll specify linear based on the value of the timer object's remaining time. Next, we'll want to display our control buttons. So create an H stack. And in that H stack, we'll create 3 buttons, one for the start timer, one for the stop timer, and one for reset. So in each case, the button will be an action with a label that uses a system image. So for the play button, the action will be the TimerObject's start timer function. And the label will be an image with the system name of play.fill. And this button will be disabled if the TimerObject's play button disabled is true. So the format for the other 2 buttons is basically going to be the same, so I can copy this code and then paste it 2 more times. The action for the pause button is stop timer, and the image is pause.fill. And it'll be disabled if the timer options pause button disabled is true. And then for the reset button, the action is reset timer. The image is go backward. And it'll be disabled when the timer option reset button disabled is true. So we can actually test this out now. And it works. We can start, pause, and reset, and our digits flip nicely as expected. But we'll want to do better than this and improve the UI a lot. So now on to improving our design. We'll want our text view to be inside a circle with a ball that rotates counterclockwise from the top around, showing the progress of the timer. So let's embed that text view in a Z-stack. Don't include the animation. Above this, create a circle with a stroke using a line width of 30. And this is going to be the background of the circle that the path moves around. So we'll set the foreground style to be a TimerObject timer color, but I'm going to set the opacity to 0.4. As I said, that's the back layer of the circle path. And then we'll apply some padding of 40 to the Z-stack to separate the controls. Then on top of this, I'll want to overlay another circle exactly the same size, but it's going to be trimmed based on the progress that we're at. So a circle where we'll trim it from 0 to the minimum of the 1 minus the TimerObject's progress and 1.0. And then I can apply a stroke, but this time we'll choose the initializer that allows us to specify content and style. So for the content, we'll use the TimerObject's timer color and apply a gradient to this. So this will be on top of that faded one. And then for the style, we'll use a stroke style, and this will allow us to specify some arguments. So we'll set the line width to 30. We'll give the line cap as it moves around to round. And then the line join will be a miter. And then we can apply a rotation effect, which is degrees, of -90. And a shadow with a radius of 2. We set it to -90 so that it'll start at the top rather than being at 3 o'clock. Now, as we tap that play button, we see that progress circle move counterclockwise. Now, it would be nice, even when the timer is running, to know what the original length was. So I'm going to embed that text view without these style modifiers in a VStack. And I'll just duplicate the text view, but I'll display the TimerObject.length property. That doesn't change. And I'll reduce the size by setting the font to 25. The last piece of the circle is the ball that'll follow the path. So below the circle, create another circle. Set the stroke to be a line width of 15. And then apply a foreground style. It's a color, but that color is going to be the same as the system background. So we'll need to use the UI color of a system background. We'll set the shadow to be a color, that is the TimerObject color, but with an opacity of 0.6 and a radius of 5. Now this is huge, so let's set a frame to a width of 40. Well, this is nice, but it's in the center. And we'll need to move it up to the top of the circle. So we're going to have to know what the radius of this big circle is so that I can set an offset. Now I'm going to go through this shortly, how to determine this, but for now, if you've set your preview to an iPhone 15 Pro, we can use an offset of -157. And then the last thing that we'll need to do is to provide a rotation effect with the number of degrees. And this is 90. And then I'll have to subtract 360 times the TimerObject progress. If I test now, you see that it's working really nicely. But we have that problem of that fixed offset. Let me move to an iPad, and we'll see we have more than just that as a problem. As you would have guessed, that rotation circle is in the wrong spot. But also that timer text is really too small for the amount of space that's been given. And the width of our timer circle should be wider in the larger view. So that's what we want to fix next. Last year, I created a couple of videos about GeometryReader, where the proxy will provide you with the dimensions of an object. And one of the things that developers often do is set the background of an object in question with a clear view so that it can calculate the dimensions of the clear view. And then the second video was on preference keys that will allow us to essentially get that value and apply it up the hierarchy so that we can modify some sort of a state property. So I'll leave a link to both of those in the description. So what I've done is to combine both techniques, and I've created a gist called ReadSize View Extension. You can find a link in the description. So go to this gist and simply click on the download zip and then unzip it. And what you can do is drag that zip file or unzipped file into your project navigator, making sure that you copy if necessary so that it's part of your project. And you can see that it uses a geometry reader and applies a clear background so that we can grab the dimensions of the provided view and then sets a size preference key. And then the ReadSize View modifier then will give us a closure that we can work with that'll generate the size that'll allow us to extract either the width or the height or both. So back in our TimerView at the top, I'm going to create a new state property called width. That'll be a CG float. And when it's initialized, I'll just initialize it as 0. And then to the Z stack before the padding, I'm going to apply a ReadSize modifier. And this will give us a trailing closure with an onChange label and a variable that we can call size. Now, since it's a trailing closure, we can remove the label and move the closing parentheses up. So we just have this. So this will be the size of the Z stack. So we can then specify that our width state property is the size's width. Well, now that we know the width of our Z stack, that's going to be the width of our circle. So we can now change the hard-coded offset to be the width divided by 2. Well, that fixes the offset. And now that we know the size, we can use it to control the dimensions of the stroke and the size of our text strings. And I've played around with this a lot, and this is what I've come up with that seems to work really well. For the top 2 circles, I'm going to change the stroke's line width to be the view's width divided by 10. And then for the rotating circle, we want that to be much smaller, so I'll use a width divided by 20. And then I can set its frame to a width divided by 8. And then to change the size of our text views, in that first text view, we can set the font size to be the width divided by 12. And then for the second text view, we can make it larger by setting the font size to a width divided by 3. And then we'll need to adjust the padding between the controls to be a width divided by 8. So it's looking good here on the iPad now. If I switch back to an iPhone 15 Pro, it still looks good. We're almost done. But we do have to apply some better modifiers to our buttons. So let's tackle the first button, and then we can generalize it with a view modifier. So first, we'll set the font to title. I'm going to set it to bold. Apply a frame with a width and height of 50. Then I'm going to set the background to be the TimerObject's timer color, but the opacity will depend on whether or not the TimerObject's play button is disabled. If it is, we'll set it to 0.5, otherwise a 1. Then we'll set the foreground style to white. Then I'll apply a clip shape of circle. So this is basically the same as what we'll do for the other buttons. So I'm going to create a new view modifier called control button style. That'll be a view modifier. And this will require a body function that takes in the content and returns some view. So we can use that content and apply our modifiers to it. So I can cut out all the modifiers, including the disabled one, and attach them to the content. Now I can't find the TimerObject timer color or the disabled Boolean property in the control button style view modifier. So I'm going to create two properties for the button style that I'll just pass in when I use the modifier. So the first will be a color, which is of type color. And the second will just be disabled, which is a Boolean. And then I can replace the complaining code with these properties. So now I can go back to my button and apply a modifier and provide the control button style, passing in the TimerObject timer color each case for the color. But for disabled, in this case, I'm going to have to pass in the TimerObject play button disabled property. So I can just copy this now and apply the same to the other buttons. And you'll find that all you need to do is change the disabled argument to match the appropriate button. Looking good so far. So there we have it, a timer that I can reuse. So let's use it. I'm going to return to Content View now, and I'm going to create 3 instances of a timer object, each one with a different color, and each one with a different length. So the first one will be red with a length of 10. Change the second one to green, length of 70. And then the third one will be blue with a length of 20. So I'm going to replace the body with an H stack containing instances of the first 2 timer objects. So let's first display the timer object with controls being true. Well, this doesn't look right. I must have forgotten something. So let me check out TimerView now. Oh, okay. This Z stack with the circle rings and the H stack with the buttons should be enclosed in a V stack. Otherwise, it'll inherit the parent, which was that H stack. So let me do that now. Okay, back in our content view, that looks better. So let me add a second timer, which is going to use TimerObject 2, and I'll apply controls as well. And we can see the timers adjust perfectly to the size provided, and they run independently. Next, let's embed the H stack in a V stack, and below that I'm going to create a third timer but set controls to false. And on this timer I'm going to set a frame of 250, and you'll see that it adjusts nicely. But I'm seeing controls, so I'm having a bad night. I forgot to make those controls conditional. So one more time back in TimerView, I'll enclose the H stack in an if clause that checks to see if the controls is true, in which case then it'll display them, otherwise it won't. So if I return now, we see that's better, no controls. So it's this third view that I want to control programmatically. And I want to start it about 5 seconds after the view appears. So I can create an onAppear modifier. And then inside there, I'll create a task unit of work. And within the body, I will try and await the results of the task sleeping for 5 seconds. And then I can call the TimerObject 3's start timer function. And then once I finish typing, the preview updates, and you'll see that in 5 seconds, the blue timer starts automatically counting down. And I can set and stop the other timers all the time while the blue one winds down. Now I think this is a really nice reusable timer view that you could convert to a framework or a Swift package, or you could just make sure that you drag the TimerObject, TimerView, and ReadSize extension files into any other project without modification, and you'll be able to use them. So I hope you found that this video was useful and you'll be able to use this timer in one of your projects. If you enjoyed the video, please give it a thumbs up and leave me a comment, and make sure you subscribe to my channel. Remember to download my free channel listing app as well so that you can easily discover more of my videos. A link is in the description.